Hello, welcome back. Today, we want to talk about testing claims about a mean. So, if you haven't seen my previous video about the basics of hypothesis testing, make sure you go back and look at that because some of the concepts we talked, discuss, and introduce in that video we use here. Our goals then are understand the meaning of hypothesis and hypothesis test. That's part of what we got from the other video. Then here we're going to test claims about the mean using the p-value method. There's also the critical value method, but here we're just going to use the p-value method and also be able to summarize the results of the test and explain it in a meaningful way. So, you saw that previous video on the basics of hypothesis testing. We talked the test statistic when testing claim about a mean depends on whether or not your standard deviation sigma is known. In most cases, it won't be known. So in that case, when it's not known, we're going to use the t-statistic here, where x is your sample mean, mu is your population mean, the one you're trying to estimate, or trying to test the claim against, rather. And also that's the mu you'll use in your hypotheses. S is your sample standard deviation. And then N is the sample size. And this is valid if the population is normally distributed, or if you're unsure if it's not normally distributed, use an N at least 30. Now, if you happen to know the standard population standard deviation, then we can basically do a, I'm sorry, this should be a typo, it should be a Z, copy and paste error. But we use a Z statistic, and that is exactly the same as this one, except here we'll use sigma, the population standard deviation. Once again, this is also valid if we know the population is already normally distributed, or if not, or unsure, use an N greater than 30. Now, to calculate the p-value, which determines then whether you're rejecting a hypothesis or not, you can do that in Excel. And here I mentioned the methods to do that in Excel, where if you're using a Z statistic, in the case if you know your standard deviation, population standard deviation, or if you don't, the value is for a t statistic. And then finally, the way we're going to go about in StatCrunch, which we'll use here as we did in the video about testing claims about proportion, we'll use StatCrunch then to find this. This is the method, the steps we'll go through, and we'll do examples of those. So let's take a look at our first example. Over here on the right, let's read this. It says, when 40 people use a specific diet plan for 1 year, their mean weight loss is 3 pounds, with a standard deviation of 4.9 pounds. Use a 0.01 significance level to test the claim that the mean weight loss is greater than 0. Then, based on these results, does the diet appear to have statistical significance? Does the diet appear to have practical significance? So those are thought questions. We'll talk about those. So once again, let's collect what we need from our data. So our N, our sample size, is 40, which is, bigger than 30, what we want. Our sample mean, our X bar, is 3.0 pounds. Our sample standard deviation S is 4.9 pounds. And then our alpha, our significance level, is 0.01. Remember, that corresponds to a 99% confidence level. Okay, now, so what we need to do is calculate our test statistic. And we can use the formula here. So we're going to use, this is going to be, we use a t-statistic. Since our sigma is unknown, we don't know anything about the actual population standard deviation. Okay. But before we get to that, let's actually write out our hypotheses. So our hypotheses we have, of course, our H0, our null hypothesis, and our H1 or HA, whichever you call it. Okay, and this is going to be about the population mean. Okay, mu. Now, remember our null is always mu equals something. And here, let's go back to our claim. And that will determine what our alternate hypothesis is. This is test the claim that the mean weight loss is greater than 0. So then this is going to be greater than 0. Then our null will be that it's equal to 0. Those are our hypotheses. Okay. So what to do next then? Here we're going to use StatCrunch. So in my previous video, I showed how to get to StatCrunch. So if you use a Pearson product, you should be available in your class, in your course site on Pearson or your My Stat Lab or something like that. You notice we already have some data over here. We'll use that later on. But here, so let's go to, our path is going to go to Stat. Then look at our options. We have T-Stats. We go to one sample. And then this time we have a choice with data or with summary. This time we have summary since we have the sample mean and sample standard deviations. You go with summary. Okay. Then we just type that in. So our sample mean was 3.0. Our sample standard deviation was 4.9. And our sample size was 40. Okay. Then our hypothesis test. Okay. In this case, our default's to 0. Actually, that's what we want to use in this case. We're testing it against 0. And here, click on the drop-down menu. You have a choice. Remember, 3 choices are not equal to, less than, or greater than. Here we want to choose greater than. And for the p-value, the p-method test is all we have to choose. Make sure everything's correct. Make sure our hypotheses are correct. Hit compute. This gives us our values. Now, once again, I'm going to copy this and then paste this into Word. And you've actually it closed. So it's actually saved here. You can go back to it at a later date. So let's do that. So give me a moment. Let me put this right below. Okay. And let's come over to the side and summarize what we have. So look at our data. Once again, our sampling we said it was 3, and it's kind of jumbled together. So pay attention where the lines are. Our degrees of freedom are 39. Now our T-stat is actually 3.87. Okay, so our T, this is the same T you'd calculate if you plugged all that in, is 2 places of 3.87, which is fairly large. It's fairly far from the mean. Okay, and that makes sense. Now our p-value is 0.0002. Okay, so if you imagine drawing a picture of what this looks like, this is what's called a one-tail test. This is greater than. So here's our population mean for 0, and our standard normal distribution 0. And way over here, then, at where the t is 3.87. Right, let me just call this, instead of calling it mu equals 0, you think of it either way, let's call it simply mu. Then the small area, in this case, since it's greater than the small area to the right, is our p-value. And that area is equal to 0.0002. Okay, so you remember then in the p-value method, you've seen other previous 2 videos, then we compare the p-value to alpha. Okay, our alpha for this test was 0.01. And our p-value, as we said, was 0.0002. Clearly, that's less. That's much smaller. In fact, it's much smaller. Okay. So we can say that we will, in this case, then we will reject the null hypothesis. Okay. Because what that means, what we're saying is, remember what this rejection means. And it's not proof that this is true, that the mean weight loss is greater than 0. But based on the statistical evidence, we can have enough evidence to reject it, that that's rejected, and then to accept the claim, or enough evidence to support the claim. Okay, so remember how the concept here is we're assuming that the mean weight loss is 0. Now, we did this sample of 40 individuals, and we got this t-statistic that was really small, really very far from the mean. In fact, the probability to the right is only about 0.002. That's about 0.02%, okay, or about 2 in 10,000. Think of it that way. So, which is more likely, that the mean actually is 0, and this sample you got a really, really, really likely value, or that the mean is actually greater than 0? And that's what we're saying, is that basically there's enough evidence to support the claim. So we just need to make that in a statement. So you say there's enough, one way to say it, enough evidence to support the claim that the mean weight loss is greater than 0. Then I usually like to say something about the significance level, say at 0.01 significance level. Okay, so at that significance level, although since such a the p-value is so small, would have been even at a 0.01 significance level. Okay, so once again, there's enough statistical evidence to say that they support this claim, the alternate hypothesis, that the mean weight loss is greater than 0 at that significance level. All right. Also, let me mention one more thing. Let's talk about, I showed you in here also how we can calculate the p-values using Excel. Let's do that for this one. I won't write anything over here. Let's do that. So the way this is grouped is to find the p-value for the t-tested statistic in Excel. If you have df degrees of freedom, remember degrees of freedom is your sample size minus 1. Then it gives 3 cases. Your alternate hypothesis is less than a number, greater than a number, or not equal to a number. So in this case, it's greater than a number. We're going to use this statement here, t.dist.rt, and then what we input is our t statistic, which is 3.87, and our degrees of freedom, which is 39, since our sample size was 40. Let's do that in Excel, show that we get the same thing. Okay, so remember, type equals for a function. And just start to type that. So t, then we have 3 choices. Make sure you pick the right one. So the RT means the right tail. It means on the right. Double click that. It tells us we have to put in the X and degrees of freedom. So our X, our t statistic, was 3.87. And our degrees of freedom was 39. It's sample size 40 minus 1. Hit enter. And you see, yeah, we get the same thing. 0.0002 makes it a couple more digits. Okay, so we can use Excel then also to find, of course, you can also calculate your test statistic by hand or with a calculator. And then also you can use Excel to find the p-value. So actually, you don't have to use StatCrunch if you don't want to, but this is a good program to use for this. Okay. Then let's look at our second example. Okay, this one says, a sample of 36 cans of Coke resulted in a mean of 12.19 ounces with a standard deviation of 0.11 ounces. Use a 0.5 significance level to test the claim that cans of Coke have a mean volume of 12 ounces. Does it appear that consumers are being cheated? I actually realized I didn't answer all the questions for number 1, so excuse me. Let's go back and take a look quickly. So the questions are, so we rejected the hypothesis. Based on these results, does the diet appear to have statistical significance? It does, because we're able to there's enough evidence to support the claim that the mean weight loss is greater than 0. Does the diet appear to have practical significance? Well, we're talking about a specific diet plan for a year, and the mean weight loss is about 3 pounds. And it's not really a lot in a year. In fact, it's possible someone's weight might fluctuate by that much, a couple pounds in a day, depending on what they've done or what they've eaten in that day. So although it has statistical significance, we were able to reject the null hypothesis. Probably doesn't have practical significance, like say 3 pounds is not really a great weight loss for an entire year. Okay, let's go back to this one. So do the same thing again. Let's write down what we have. So we have a sample of 36, which is good because we don't know anything about the population, not assume that it's normal. So we want at least 30. Our sample mean was 12.09 ounces. The sample standard deviation S is 0.11. And then significance level alpha is 0.05. Now, let's write our hypotheses. So H0 and H1. Once again, we're talking about the mean. And also the clue that it's a mean, not proportion, it says things like mean or average. In proportion, it would say something like a percent. Okay, so remember, the null hypothesis is always equal to something. Now, let's check the claim to see what our alternate hypothesis looks like. The claim that the cans of Coke have a mean volume of 12 ounces. So this is one of the cases where our claim is actually the same as our null. But since we're not talking about greater than or equal than, then our alternate would just be that it's not equal. I'm sorry, not equal to 0. Hang on. Thinking about the last one. So have a mean volume of 12 ounces. Okay. And so then our null, it turns out the claim is the same as our null hypothesis. So then, since you never asked about greater or less than this value, our alternate will be that it's not equal to 12. Once again, we're going to use StatCrunch. To work out the details. Let's go back to that. So once again, we're going to go to Stat, to T-Stats, one sample, and once again, this time we have a summary since we have the mean and standard deviation. Okay, so the sample mean was 12.19. Sample standard deviation was 0.11. And the sample size was 36. Okay, then make sure you correct your hypotheses. So the null was that mu is equal to 12. And then the default actually is not equal. That's when we want to choose. So double check, make sure this is correct. Sample mean, standard deviation, sample size are correct, and our hypotheses are correct and what not equal. And so just hit compute, and that will give you your values. So once again, as before, let me copy these and we'll paste these into our Word document. And I can also close this and save it for later. See, it appears there. So if you want those later, see its results for 2 are hidden. So you can always click on them again if you want to see them again. Let's go right here and paste that. And then let's write down what we need from StatCrunch. Okay, so what we need is our test statistic. Standard error we don't need. Degrees of freedom also don't need that, but that's 35. It's n minus 1. Our test statistic is really large. Okay, t is equal to 10.36. So you imagine we're probably going to be rejecting because our p-value, in fact, the p-value doesn't give us the exact value. It just says that it's less than 0.0001. So it's very small. Okay. Now, so imagine a picture of what we have. And this is what's known as a two-tail test, because here, once again, here's our mean, our mu. We're interested in 2 regions. This should be symmetric. So our t is going to be 10.37, or 36 rather. Since it's not equal, and also down here we'd have the t of negative 10.36. And so our p-value, each one of these, is the p-value divided by 2. Okay. And so then the question is, what's the probability, what's the area under the curve of each one of these little parts multiplied by 2? What's the area under there? And basically, those are values that are just more extreme. The t statistics are the cutoff of those values. Those values that are more extreme are further from the mean than our t. And basically, if that probability is less than our significance level, then we reject. So look, then we want to compare the p-value to alpha. So our p-value, I would simply say, as it says, it's less than 0.0001. And our alpha this time is 0.05. So clearly, that's less. Okay. So once again, we can reject the null hypothesis. And actually, we probably actually in both cases, let me go back and circle that so make sure that's clear and find it. So we're rejecting the null hypothesis based on the p-value test. And also, if you did a critical value test, you would also get the same result. Okay. Now, so once again, let's go back then and summarize what this says. Is that the claim was a claim we're rejecting null, and the claim was that cans of Coke have a mean of volume of 12 ounces. So we can actually reject that then. In this case, the claim is the same as the null hypothesis, so we can reject that. So there's enough evidence to or let me say it this way, it's even better to say there's enough evidence well, it's the best way to say it. To reject. Yeah, I guess I can say it the way I was about to. Thinking in my head if it's a better way to say it, but this is good. Reject the claim that the mean or average Coke can volume is 12.00 ounces. Okay, once again, at the significance level, so at 0.05 significance level. Okay, there's enough evidence to reject the claim that the mean Coke can volume is 12 ounces at that level. Now here, since our hypothesis is stated is basically equal to and not equal to for the null, we can't say from the test whether one is greater than that or less than that. Okay, we can simply say that reject the claim that is equal to that. But so the next question that is to be done different. Now, if the claim been different, we said the claim was that the mean was greater than 12, then we could say a direction one or the other. But that's wasn't the hypothesis. The other question does it appear the consumer is being cheated? Okay, in this case, we'd say no, because if it's labeled as a 12-ounce can of Coke, and basically, remember we got our sample was larger than 12, and then our t statistic was a lot larger than the mean. That suggests most likely that although this wasn't part of the hypothesis, it would appear this isn't part of the formal statement, but it would appear that Coke cans have more than 12 ounces on average. And then so if the consumer is not being cheated, actually getting a little bit more than what it claims. But that isn't actually part of the hypothesis test. The hypothesis test for just rejecting the claim that is equal to that. Okay. But it appears from the data, appears that it's going to be more. Okay. Next one. Oops. And hang on. Actually, I realize oops. I apologize. I realize I actually picked one. This is actually a bad example. This is actually about proportion. So I apologize for that. Okay, let's just go down to that's okay. Let's go down to the next one. Right. I wasn't paying attention and I actually picked one for proportion. It's a good example for proportion that's not about a mean. Okay, so let's take a look. I'll change this to our number 3 then. Okay, so listed below are the heights of a simple random sample of female supermodels. Use a 0.01 significance level to test the claim that supermodels have an average height greater than the average height of 162 centimeters for women in the general population. With only 16 values, can we really conclude that supermodels are taller than the typical woman? Okay, so once again, let's write down our details. Here it says we have 16 values, so we know that n is 16. And we also know that our significance level is going to be alpha is going to be 0.01. That's all we know. We're just given the data this time. Okay, so I want to talk about how to do that, how to take care of this problem. But also let's go and do our hypotheses as well. So H0 and H1 or HA. And here, so let's look at our claim. Let's look at our H0. This is about a mean. And we know the H0 is going to be mean is equal to something. But let's see our claim. The claim that supermodels have an average height greater than the average height of women, which is 162 centimeters. So the mean is greater than 162. And then, of course, the null hypothesis would be that it's equal to 162. Okay. Now, once again, we're going to use StatCrunch, this time with the data. Okay. And so that's going to be very similar to what we did and towards how to get there, but it'll be slightly different than what we do. So if you look back on the left, I actually talked about this. So if you have data, if you have the data, do the same thing except you choose with data at the end. So let's take a look at that on StatCrunch. And that's what I already have. So I already put our data here. That's the data we're going to use. So go to Stat. Once again, go back to T-Stats. The only thing is different is the last step. T-Stats, one sample, and then this time with data. Okay. And what's going to ask you to do then is just select the columns you want in variable 1 is where we have our data. So select that. Okay. And then the rest of it's exactly the same. Make sure our hypothesis is correct. So this was greater than 162 for our null, or equal to 162 for the null. And for the alternate, HA, wanted to choose greater than. Okay, so once again, double check, make sure everything is right. We chose the correct column. Okay, our hypothesis, our null hypothesis is mu is equal to 162. The alternate is mu is greater than 162, and that's it. So hit compute. And once again, the same thing. Let's copy this and paste this into our Word document. Okay. Now, one thing that actually doesn't tell us here, as we'll see, look at what we have, okay, actually gives our sample mean. We didn't have that before. Our sample mean, X bar, is actually equal to 177.25. Now, interestingly, it doesn't actually give us the standard deviation. The standard error is not the same as standard deviation, okay? If you want to find the standard deviation, I'll show you how to do that in a moment with StatCrunch. But what we need to do then is then get our test statistic. And you see it's really big. So 33.08. Imagine that's going to reject the null hypothesis in pretty much every situation. Okay. Their p-value is, or for a t-statistic that large, p-value is going to be less than 0.0001. Okay. So if we drew this one, this picture is going to be similar to the last one we did. So we have our mu, and then here, way over here, way over here is actually our test statistic of 33.08, and then here's our p-value, which is less than 0.001. Or I won't write it. We'll just say that that's the p-value right here. That's what it represents, is that probability of that area under the curve, or the probability you'll pick a value from this region. This is the t statistic is the cutoff. So basically it's saying that this, so we compare this area to the significance level just as before. Okay, and so the p-value is less than 0.0001, and the alpha is 0.005 or 0.1. 0.1 actually, but still it doesn't matter because it's clearly less. Okay, so in this case, once again, we're going to reject our null hypothesis. Okay, so let's summarize that. So the claim was that supermodels have an average height greater than the average height of women. And so that's what there's enough evidence to support that claim then. So there's enough evidence to support the claim that female supermodels have an average, that average height greater than 162 centimeters, which once again is this is the average height for women in general. Let's say for women. Okay, once again, at our significance level of 0.01. So at 0.01 significance level, let's abbreviate that. Okay, so we read that back again. Okay, enough evidence to support the claim that female supermodels have an average height greater than 162 centimeters, which is the average height for women in general, at 0.1 significance level. I'm also going to add one thing to this. I'll say even though is one thing we haven't really talked about yet. Even though n, our sample size, is less than 30. Okay, so we said generally what we want is we want our sample size. If we're not talking only thing about the population, we want our sample size to be greater than 30. Okay, and that has to do with the central limit theorem and being able to use the central limit theorem. Now, women's heights in general are normally distributed, but we're not sure that supermodel heights are necessarily normally distributed. So there is some concern by the fact that we only have 16. But since we can say this, since we got such a large t value, okay, since the p value for this was so large, okay, incredibly large, 33, okay, that we're pretty confident that we can still make this claim even though our sample size is not as large as we'd like, because it's such a large difference. So in other words, if the t of the sample, random sample of supermodels gives us a t statistic or a value that much different from the mean, that much larger than the mean, then what's more likely, that supermodels are average height, or they're much larger than average height, or they're larger than average height, and that's what this shows. Now, actually, the example I incorrectly put in was going to be the one where actually we'd actually not reject the null hypothesis. But we haven't seen one that we did that in that case, but it works exactly the same. So if your p-value, which one's going to get from StatCrunch, is larger than your significance level, the significance level is given to you, then you don't reject the null hypothesis. So for example, if this p-value had been, say, 0.05, for example, we'd have said we would not reject the null hypothesis. And then we'd say there's not enough evidence to support the claim. So essentially, we essentially add here a not enough evidence to support the claim if that had been the case. So even though we haven't seen that with this, also you saw some examples of that, of not rejecting the null hypothesis in the previous video on testing claims about proportion. So in that case, if the p-value is larger than alpha, you don't reject, say not reject the null hypothesis. Essentially, you just added this statement. If that was the case, you say not enough evidence, then the rest would be the same. So what we learned today then is how to test a claim about a mean. We've learned that in most cases, what will be the true is you won't know your population standard deviation, so use a t statistic, a t-test. You can also use Excel to find those p-values, okay, for if you're using a z-statistic, if you know the population standard deviation, or if not, which is most cases, use from the t distribution, determine that. I'll give you the 3 cases. And then we talk about how to do this on StatCrunch to do that. In both ways with StatCrunch, also how to enter data with a summary and also how to do it with data itself. And so that's how you then test a claim about a mean. Thank you. Have a good day.